we will continue with the interpretation of Likert scale row scores. So there are 4 ways for the interpretation. We can calculate different new variables which are easy for interpretation. Likert scale row scores are not easy for interpretation, and for that reason we create new variables. The first way is to calculate average scores. Since we use score scale with 5 scores and we sum answers of 6 items or 6 statements, we can divide row score by 6. And here in PSPP, I will finish this file. We'll close without saving. In PSPP, I can choose transform, compute again. Since I already have computed this scale optimism, I can press reset and start from the beginning. The new variable will be optimism underline average. And the equation will be optimism. So I will move optimism from left to the right, divided by 6, since our scale has 6 items, 6 statements. And then, okay, and then here, in the data file, in data view, we have this new column with optimism average, and we can see that the first person, now data file, has average score of 3.17, the second also 3.17, the third 3.83, and the fourth 4, the sixth 5, and so on and so on. And why I said that this is easy for interpretation? Again, I will use whiteboard and we will open new. Sorry. Open new whiteboard. So we started with score scale with 5 categories from 1 to 5. 1, 2, 3, 4, 5. After that, we sum answers of 6 items and obtain the row scores. But the lowest row score is 6, because one individual could choose only answer 1, only first category, and 6, 1 makes 6. the largest value is 30 because one person could choose only fives, and 6 fives makes 30. So the row scores are between 6 and 30. If we divide the row scores by 6, the lowest value is 6 divided by 6. This is 1. The largest value is 13 divided by 6. This is 5. But 7 divided by 6 is not 2. 7 divided by 6 is here. 8 divided by 6 is here. 9, 10, 11, and 12 divided by 6 is 2. After that, 13 divided by 6, 14, 15, 16, 17, 18 is 3, and so on. So when we calculate this average score, we are again between 1 and 5, but the distance between 2 points of this scale, the distance is smaller than 1. Here, I already said that score scale is not interval scale. It's a special case of ordinal scale, because the difference between two scores is always 1. The difference between 1 and 2 is 1. The difference between 2 and 3 is also 1. The difference between 3 and 4 is also 1, and so on. Here, difference between two values is smaller. And that means that using these average scores, we can measure distance more precisely. So if, for example, we have a person with these results and other person with these results, we can more precisely measure the distance between these two individuals. But this is only one advantage of average score. The second one is that we already know what is 1, what is 2, what is 3. So we already know that 1 is strongly disagree, 2 is rather disagree, 3 is neither nor, 4 is rather agree, and 5 is strongly agree. And here, this person, his or her average score is almost 3. That means that this person is neither nor. Neither disagree nor agree. But here, this person, 3.8 is almost 4. That means that this person is rather agree. Also here, the result is 4, rather agree. Here, the result is 5, strongly agree. And here, the result is 1.7. This is almost 2, So we can say here that this person is rather disagree, and so on and so on. So the first way, the first key for interpretation is to calculate average scores. The second key, how to compute, we already computed, already have these results. The second key is to define the norm, and we already did. We already defined the norm. Yes, using normal distribution, and here in the Word file we calculated these borders. But since we sum numbers which are 1, 2, 3, 4, 5, the results are always whole numbers. They have not decimal places, decimal digits. So I can write here that all values which are less than or equal to 17 show below the norm. All values between 18 and 26 show in the norm. And all values equal to or greater than 27 are above the norm. And I can create new variable in the PSPP with these three categories. Now, in SPSS, there are two ways to create this new variable. One of them is easier, and the second is more difficult. Unfortunately, in PSPP, there is only one way, and this is the difficult way. So I will create this new variable in the PSPP. I will choose them. After that, I repeat code into different variables. Again, I will press reset to start from the beginning. And then I will take variable optimism, move to the right, and then define new name, optimism. I will again use letter R because we use this record, this option code. After that, I will press here change, and we will press Alt and new values. And here we have three intervals. The first interval is up to 17. So here I will choose range lowest true value, and we'll type here 17, and will give new value 1 and then press 1. Lowest to from lowest to 17 is 1. After that, second interval is between 18 and 26. So here I will type 18 through 26. New values. Here new value is 2. And again, and the last interval is above 27. So I will choose here range value to highest. I will type 27. New value is 3. And again 8. So all values from lowest to 17 become 1. All values between 18 and 26 become 2. And all values between 27 and highest become 3. And then continue. And then OK. And then OK. And then here we have new variable optimism R. And these are the values 2, 3, 1, and so on. But in variable view, here we have to define these categories. So here double click. 1 is below the norm, 2 is in the norm, and 3 is above the norm. And after that, here in data view, we can press show hide value labels, and here for each person we already know whether he or she is in the norm, above the norm, or below the norm. So here the first 4 individuals are in the norm, the 5th individual is above the norm, and for example here 11th is below the norm, and so on and so on. So in this way, using normal distribution and borders between mean minus 1 standard deviation to mean plus 1 standard deviation, we can create these categories for each person. And this was the second key for the interpretation. So the third key, as I already said, here in the presentation is shown the easier way in the SPSS. This more difficult way is not shown in the presentation. But the result is the same. New variable with categories. Norm, above the norm, below the norm. So, since we already have this new variable, we could check again the normality of distribution. If our empirical distribution is normal, we expect that in the norm will be almost 68% of individuals, and below the norm, in this interval, below the norm, there will be almost 16% of individuals, and above the norm, will be almost 16% of individuals. We can check this. We can check this by using analyze. After that, descriptive statistics. After that, frequency, and move this new variable optimism R from left to the right. This is enough. Just check OK. And let's see the results. Results here. So we have to see here valid percent, and we have almost 15% below the norm, almost 68% in the norm, and 17.5% above the norm. These numbers are not exactly the same as 16, 68, and 16, but are very close. They are very close. Here we have 14.7. After that, 67.8. 67.8%. After that, 17.5%. Okay. So not the same, but very close. So we can conclude that our distribution, again, we can conclude that our distribution is very close to the normal distribution. So let's continue. The percents are the same as in PSPP. And we will go to the third key for interpretation. The third key are so-called standardized values, or also Z-scores. What does that mean, Z-scores? To calculate Z-score from scale minus mean and divided by standard deviation. And the question again is why? Why we should do this? And answer is again here the normal distribution, because if the raw score of one individual is equal to the mean, then him or her Z-score will be 0. If one individual is here, it's his or her raw score is equal to mean minus 1 standard deviation, his or her raw score will be -1. And if one individual is here, if his or her raw score is equal to mean plus 1 standard deviation, his or her Z-score will be 1. So when we have these Z-scores, we can say whether this particular individual is in the norm or below the norm or above the norm. And also we can say where in the norm, or where below the norm, or where above the norm. And let's calculate and then show this this meaning. To calculate, we have to choose analyze. After that, again, descriptive statistics, but now descriptives. And again, move optimism from left to right, optimism from left to the right. And here we have options. Save z-scores of selected variables as new variable. We must check these options, then press OK. And then here appears new variable z-score. Z-score 1. This is previous one from the previous year. Z-score 2 is this new calculated variable. So the first individual has z-score minus 0.7. That means that 0.7, this value is between -1 and +1, and this individual is in the norm, but 0.7 is here in the norm, close to the lower limit, to the lower border. The second individual is also 0.7. The third 0.2, between -1 and +1, so in the norm, but plus 0.2 is here, close to 0. So the fifth individual is 1.8. 1.8 is greater than 1, so this individual is above the norm, and 1.8 is maybe here. The 11th individual here is minus 2.7. Minus 2.7 is less than -1, so this individual is below the norm, and minus 2.7 is out of screen, maybe here. So when we have calculated these z-scores, we can say whether one particular person is below the norm, in the norm, or above the norm. And also we can say that we can say where in the norm, or below the norm, or above the norm he or she is. So this was the third way, the third key for interpretation, standardization or standardized value or z-scores. Here in SPSS, the calculation is almost the same, but the words are different. In PSPP was save z-scores, here save standardized values, but standardized values and z-scores are the same. Here is the result, and the result is the same as PSPP. Now, before the fourth way, the first key for interpretation, we will continue with the third, because we can calculate the so-called t-scores. When we already have z-scores, we can calculate t-scores. And the equation is, now you use different color, t-score is equal to z-scores multiplied by 10 plus 15. And the question again is why? To answer this question, let's again see these special cases. Mean minus 1 standard deviation, and mean plus 1 standard deviation. When if one person, if his or her row score is equal to the mean, then his or her z-score will be 0. Then his or her t-score will be 50. If row scores of one particular person or row score is equal to mean minus 1 standard deviation, then his or her z-score will be minus 1. Then his or her t-score will be 40. And if row score of one particular person is equal to the mean plus 1 standard deviation, then his or her z-score will be 1, and then his or her t-score will be 60. So the reason for using a t-scores is that t-scores is very look like percentages. So here in the middle, if the row score is equal to the mean, in the middle we have 50. This is not 50%, but the number is the same. We know that when we use percentages, 50% is in the middle. Here, t-score 50 is also in the middle. So these t-scores are very similar, external similarity. This similarity is external. They are not percentages, but they look like percentages. So for the calculation of this t-scores, we must use the equation. We can choose here put again. Again, press reset to start from the beginning. And then type new name, for example, t-optimism, t-scores of optimism, and then move z-scores, because here the direction is from z-scores to t-scores. So move z-scores, then multiply by 10 and plus 50. And then we have new variable here, the optimism, with this with this t-scores. T-score also shows the norm, below the norm, above the norm, because if the t-score is between 40 and 60, then the individual is in the norm. If the t-score is below 40, then the individual is below the norm. And if the t-score is above 60, then the individual is above the norm. So here, the first individual has t-score of 43. 43 between 40 and 60 in the norm, and 43 is here. These marks are the same. The scale is different, but the marks are the same. The second also has t-score of 43. The third has the t-score of 52. 52 is between 40 and 60. It is also in the norm, and 52 is here, and so on, so on. For example, this fifth person who is above the norm, the t-score is 68. 68 is here, above the norm, and this 11th person who is below the norm, 23 t-score, 23 is here, and so on. So different ways to show the same thing, to show whether this person is below the norm, in the norm, or above the norm, and in the same time to show where below, where in, or where above the norm this person is. So this was the third way, and now we will continue with the fourth way. Sorry. Sorry. How to calculate this course in SPSS is exactly the same as in PSPP. The last way, the last key is so-called index. The index is the result from other transformation, and this transformation is called normalization. We can make normalization when we know the lowest and the largest value of one variable, but theoretically. So this means that x minimum is theoretical minimum, and x maximum is theoretical maximum. Then we can recalculate this interval, these borders, these limits of interval, to become 0 and 1. First, from all three parts of this equation, of this formula, we take x minimum, So x minimum minus x minimum, the result is 0. And after that, x minus x minimum and x maximum minus x minimum. After that, we divide all three parts of this formula, divide by the upper limit. So 0 divided by upper limit is 0. Upper limit divided by itself is 1. And here we have the new variable, which is between 0 and 1. And if we multiply these results by 100, we will obtain so-called index. We multiply by 100 again to obtain numbers which are similar to the percentages. Again, they are not percentages, but they are external similarity to percentages. And reason is that we know how to we know the proper interpretation of the percentage. And when a number is similar to the percentage, we can make our interpretation easier. So again, let's calculate this index. But now we have we must calculate before that the exact form of the equation. So different color index is equal to scale minus theoretical minimum. In our case, theoretical minimum of this scale of optimism is 6, divided by the difference between theoretical maximum and theoretical minimum. Theoretical maximum is 30, theoretical minimum is 6, and multiplied by 100. So the final equation is scale minus 6 divided by 24 and multiplied by 100. So again transform, again compute, again reset, new name, index optimism, and the equation is optimism minus 6, this in parentheses, divided by 24 and multiplied by 100. And then, okay, and then here is this new variable, index optimism, and here we can see the numbers: 54, 71, 75, 100, and so on and so on. So after these 4 keys for interpretation, I want to make some summary, some conclusions. And first of all, I want to show similarity between these two ways, between average scores and index. Here, the similarity is, in fact, that for calculation of average scores and for calculation of index, we use constants. In the first case, when we calculate average scores, we use number of items, number of statements. We here we divided scale divided by 6, but 6 is number of items, and this number is constant. When we calculated index here, we use 6 and 30, but 6 and 30 are constants because they are theoretical minimum and theoretical maximum. So in both cases, we use constants. That means that we can use these ways. We can use average scores or index for the comparative analysis between different groups. For example, if we use the same questionnaire in Bulgaria or in Germany, for example, we can compare Bulgarian population and German population because again, I will start with new whiteboard. So if, for example, here we have row scores between, in our case, between 6 and 13, and have two different populations, Bulgarian population and German population. When we calculate average score or index, we only change the scale. So if we calculate average score, our scale will be from 1 to 5. But these two distributions remain the same. They are not changed. If we calculate index, the scale become from 0 to 100. But again, these two distributions remain the same. They are not changed. So, if we use average scores or index, we can use these transformations for the comparative analysis. But possibility to use these transformations for comparative analysis is advantage of them, but there is one disadvantage, and this is the fact that these numbers do not show the norm. Here, average optimism. When we see here 3.17, we don't know nothing. We don't know anything about the norm. Whether this person is in the norm or not, we can't say from here, from this number. Exactly the same is situation with index. Here, this number, 54.17, don't tell us anything about the norm. I don't know whether this person is in the norm or not. So this is the disadvantage of these two transformations. Now, similarity between other two transformations is that here we use mean and standard deviation. For calculation of norm, we use mean and standard deviation, and calculate these limits, upper and lower limit as mean minus 1 and mean plus 1 standard deviation. And when we calculate z-scores, we also use mean and standard deviation, but these are means and standard deviations of particular population. So if we use the same questionnaire in Bulgaria and in Germany, for example, for Bulgaria, we will use Bulgarian mean and Bulgarian standard deviation. And for German, we will use German mean and German standard deviation. That means that these values, these numbers, are not appropriate for the comparative analysis, because when we standardized with mean and standard deviation of each population, then we lose the difference between distribution. Then this red distribution will be here, and green distribution will be also here. And these two distributions will become equal, will become the same. And when we use z-scores, here will be 0, here will be plus 1, here will be minus 1. And if we use t-scores, here will be 50, here will be 60, here will be 40. But the distribution, the two distributions become equal. So we cannot use these transformations for the comparative analysis. But the advantage is that these numbers show the norm. In the case of this variable, optimism R, here, we can see the norm directly. Here we have categories: in the norm, above the norm, below the norm. In the case of z-scores, we also can see the norm, because the numbers between -1 and +1 are in the norm. Below -1, is below the norm, and above +1 is above the norm. And here, t-scores the same. Numbers between 40 and 60 are in the norm. Numbers below the 40 are below the norm, and numbers above the 60 are above the norm. So you can see that average scores and index are similar on one hand. On the other hand, norm, z-scores, and t-scores are similar. But on third hand, these two transformations are opposite to these two transformations. Advantages of this are disadvantages of this, and opposite. Advantages of this are disadvantages of this. So when you work with a questionnaire with scale, you must choose. We never use all 5 transformations. We only choose only one transformation, and you must choose only one transformation, but you have to know advantages and disadvantages of these transformations. So this was the first topic, not the first in the syllabus, but the first for us, topic for simple and complex scales. Questions? Okay, I will stop recording.